everybody. In this video, we are going to learn about the basic concepts of an ideal op-amp. So first, we should know what is an op-amp. Op-amp is an operational amplifier. So this symbol shows the operational amplifier. Then what is an ideal op-amp? Ideal is the perfect, but it is not realistic. Okay, so it cannot be realized in real life. So real op-amp is different from ideal one. So what are all the conditions we are expecting perfectly is coming under the word ideal. So today we are going to see about the basic concepts of an ideal op-amp. So op-amp is the short form of operational amplifier. So in this we know the word amplifier indicates that it is a electric circuit or electronic circuit which amplifies the signal. Okay. So amplifying the signal means it may be a voltage signal or the current signal. Then what about this operational, the word operational that indicates particular component, particular device that can perform various operations like inversion, summation, integration and differentiation and many more. Hence we call this as operational amplifier. And now we move on to the structure or the circuit symbol or the circuit schematic of this operational amplifier. So it is triangle in shape, and basically we mentioned two input terminals and one output terminal. Other than that, we can also include two more, that is for power supply. Okay, one is positive power, another one is negative power supply. So these two terminals, that means these two input terminals are named as negative terminal and the positive terminal, but actually we call them as inverting terminal and the non-inverting terminal. So here we have this minus sign. Okay, that indicates it is the inverting terminal, and this one indicates it is a non-inverting terminal, and this is your output terminal. And now we are going to see about the important characteristics of this ideal op-amp. In this, the first point is the open loop voltage gain is equal to infinity, that is mentioned as AOL. Okay, open loop, that is equal to infinity. So you have infinite gain while it is in the open loop. So what is the meaning of open loop and the closed loop? Open loop means the output is not fed back as the input, right? You are giving some input and you are getting some output. That's it. It is the open loop. There's no feedback path from outside to input side. So for that open loop condition, the gain is infinite. And the input impedance of this op-amp is infinity. That means Zn is equal to infinity. So what's the meaning of it? So at the input sign, if you measure the impedance, then that impedance value is infinity. Then the third point and the last point is output impedance. Z out is equal to 0. So when you are looking into this output terminal, that impedance is equal to 0. So these are all the three important characteristics of an ideal op-amp. This op-amp acts as an open circuit for input currents. The op-amp acts as the short circuit for input voltage. What is the meaning of it? So now we'll see that points one by one. The op-amp acts as open circuit for input currents. So no current will be entering into this input terminals. So if you name this as I minus, that is the current which is entering into this negative terminal or the inverting terminal, that would be actually equal to 0. No current can enter into this terminal. Similarly here, this I plus, that is the current which is entering into this non-inverting terminal is equal to 0. So actually is it possible? Because we know that this Rin or the input impedance or the input resistance of this op-amp is infinity. Since it is of very high value, no current can enter into that. Point we should always keep in mind. This is the golden to be kept in mind while you are solving the problems. Okay. This is the second golden rule. So VD is equal to VA minus VB, that is equal to 0. So what it is actually? This is the mathematical expression for op-amp acts as short circuit for input voltages. Okay, so this is it. So VD equal to VA minus VB equal to 0 means when you take this potential at this inverting terminal as VA, and if you take this potential at non-inverting terminal as VB, then the difference between these two will be taken as VD, and definitely it will be equal to 0. This is known as difference voltage or the error voltage at the input terminals. Okay, this is another important concept that indicates that we have equal voltages at the input terminals. Okay, suppose if you have VA equal to 1 volt, definitely VB will also be equal to 1 volt. When you ground this B terminal, so VB equal to 0. At that time, this A terminal or the A node is also acting like grounded, so that we can get this concept VD equal to 0. So actually this A terminal is not grounded, but it is acting like a ground, right? So that we call it as a virtual ground and not the real ground. Okay. Similarly, as this voltage difference VD equal to 0, that indicates there is a short between these two terminals A and B. And this is called as virtual short. With this concept, we'll end this video and we'll see the inverting amplifier in the next video.